Introduction. What is agent-to-agent architecture? Why it matters in the AI era. Key benefits: scalability, autonomy, resilience. Today we'll explore agent-to-agent architecture, a way of designing intelligent systems where autonomous agents collaborate to solve problems. This approach is reshaping how we think about scalability, autonomy, and resilience in AI systems. Core concept. Agents equals autonomous software entities with goals, memory, and communication channels. Architecture equals system where agents collaborate, negotiate, and orchestrate tasks. Analogy: distributed microservices, but with intelligence and adaptability. Think of agents as autonomous software entities with their own goals, memory, and communication channels. Instead of a single monolithic system, we build ecosystems where agents negotiate, share tasks, and orchestrate workflows. It's like microservices, but with intelligence and adaptability built in. Pitfalls to avoid. Error compounding across agents. Conformity bias, same model blind spots, shared state conflicts. Context rot in long conversations. Infinite loops in agent handoffs. Of course, multi-agent systems aren't without challenges. Errors can compound across agents. Shared state can cause conflicts. Long conversations can lead to context rot. And without guardrails, agents can fall into infinite loops. Recognizing these pitfalls early is key to designing robust systems. Design principles. Typed schemas and contracts. Enforce strict message formats. Verification agents. Dedicated roles for fact-checking. Guardrails. Iteration caps, timeouts, done criteria. Orchestration layer. Explicit task decomposition and ordering. Monitoring and logging. Structured logs for drift detection. To mitigate these risks, we rely on strong design principles. Typed schemas and contracts enforce strict communication. Verification agents fact-check outputs. Guardrails like iteration caps and timeouts prevent runaway loops. And orchestration layers ensure tasks are decomposed and ordered correctly. Implementation steps. Define roles: planner, executor, verifier, communicator. Set communication protocols, JSON schemas, APIs, message queues. Choose orchestration frameworks, LangChain, CrewAI, AutoGen, or custom pipelines. Integrate diverse models, reduce monoculture bias. Establish governance, authority roles to break deadlocks. Implementation begins with defining clear agent roles: planner, executor, verifier, communicator. Next, we establish communication protocols, often using JSON schemas or APIs. We select orchestration frameworks like LangChain, CrewAI, or AutoGen. Then we integrate diverse models to reduce bias, and finally, we set governance rules to break deadlocks. Technical stack. Front-end, user interface for inputs/outputs. Back-end, orchestration engine, task manager, router, AI layer, LLMs, specialized models, retrieval system. Storage, vector databases, knowledge bases, logs. Monitoring, dashboards, alerts, audit trails. From a technical perspective, a stack includes a front-end for user interaction, a back-end orchestration engine, an AI layer with LLMs and retrieval systems, storage for knowledge bases and logs, and monitoring dashboards to track performance and detect drift. Case study example. Workflow automation in customer support. Agent A understands query. Agent B retrieves knowledge base. Agent C validates response. Agent D delivers final answer outcome, reduced latency, higher accuracy, autonomous escalation. Let's take customer support as an example. Agent A interprets the query. Agent B retrieves knowledge base entries. Agent C validates the response. Agent D delivers the final answer. This reduces latency, improves accuracy, and allows autonomous escalation when needed. Best practices. Start small, 2 to 3 agents with clear roles. Use diverse models for redundancy. Build in fail-fast mechanisms. Continuously retrain and refresh. Context align with ethical AI principles. Best practices include starting small with 2 or 3 agents, using diverse models for redundancy, building fail-fast mechanisms, continuously refreshing context, and aligning with ethical AI principles. These steps ensure systems remain reliable and trustworthy. Future outlook. Multi-agent ecosystems across industries, finance, healthcare, logistics, AI-native architectures replacing traditional workflows. Human-in-the-loop governance for trust and accountability. Looking ahead, we'll see multi-agent ecosystems across industries, finance, healthcare, logistics. AI-native architectures will replace traditional workflows. And human-in-the-loop governance will remain essential for trust and accountability. Closing thought. Agent-to-agent architecture isn't just about smarter systems, it's about designing collaboration at scale. The engineers who master orchestration, governance, and ethical design will lead the next wave of AI innovation.